is Charlie from Chemistry 172. My lab section is Friday from 2 to 4. And I just wanted to give a little report on what's been going on with the alum crystals, their growth, etc. So the solution that we made in class is right here. As you can see, there's not that much growth to the alum crystals, at least none visible to the naked eye at the moment, which does make sense. It's only been a few days since last Friday. But I just wanted to share the entire process, the reactions involved, and how we just generally make the alum crystals. So to make the crystals, we use several reactions to separate the aluminum ions from aluminum foil, which then we use to precipitate crystalline alum. So to begin, we dissolved 1 gram of a piece of aluminum foil into a solution of potassium hydroxide. And what this does is it forms a aluminum hydroxide solution, which then can be mixed with 9 molar sulfuric acid to precipitate the aluminum hydroxide. But during the lab, this was not super clear at which point did this step completely finish, because as we added more sulfuric acid and heat and stirring, the addition of the sulfuric acid precipitated as well as dissolved the aluminum hydroxide back into aluminum ions. And so when we cooled this into an ice bath, all the ions began to form crystalline alum, because finally we had these separated aluminum ions in solution. And so the next step for the creation of the alum crystals, or for this experiment, was to clean and purify the alum crystals that precipitated out of the solution. So our first step was vacuum filtration. That's generally the first step to cleaning anything. But since the alum crystals were relatively messy, not all of the alum crystals, or it wasn't completely clean. So we decided to add a around 50-50 ratio of ethanol and water to separate all the remnant ions left on the alum. And we did this 3 times over, and we were left with a pile of, at least as close as we could get, alum. So finally, we used 5 grams of the alum, and calculating how much water we needed using the solubility rules, grams to milliliters. We used around 40 milliliters of the water to supersaturate the alum. And because after you supersaturate the alum and then you let the solution evaporate, then what's left is just the crystals. So because our lab group has 2 people, we separated the solution into around 20 milliliter vials, which we have here, which will eventually evaporate and then produce the crystals that we want. So that's the general overview of what we did in this lab. I hope it gave a pretty clear description on all the reactions and processes involved. All the data, all the numbers can just be found on lab archives. So the other thing that we have to record or report for the post-lab is 2 questions. The first one being that how would we approach growing crystals of NaCl, or table salt? And so this should be very similar to the growth of the alum crystals, but should be much simpler because unlike aluminum, table salt easily dissolves in water itself, so we can skip a few steps there. So to create the crystals for sodium chloride, all we would need to do is take however much salt we wanted, and then pour it into a pot, a batch of boiling hot water, and just use enough water to have all the salt dissolve, because at this point then the solution is super saturated. And since this solution is much easier with that, unlike the alum, which we went through many different reactions to finally get it super saturated, after boiling the salt into water, it should already be super saturated. So when it cools, it should already form the crystals of NaCl after it all evaporates. And so the other question is a bit less simple, but it asks, give another example of a way to grow a crystal. And so for this one, we can just stick with the same basic materials as this one right here. And so the first step would just be to separate it out into the alum again. So using the potassium hydroxide and using the sulfuric acid 9 molar, just have an alum solution there. So what this different way of creating this crystal would do is bypass the entire step where the final step really, where the alum is precipitated and then put it into a water solution to supersaturate it. So this way we would just use, after all the reactions happen, use the alum and then put it into a container with very hot water and then stir it. So this makes it saturated. And so this should, after evaporating a little bit, already create the crystals. So after that, we would make another saturated solution of the alum and then take one of the crystals, preferably one of the bigger ones, from that saturated solution and then put it straight into the other saturated alum solution. And so that it is very similar to this solution right here, but while this one focuses on one target point of the alum, which then after evaporating creates many crystals, this one mostly focuses on using one of the initial crystals that precipitate and then using a process, or like by a process of nucleation, putting it into another alum saturated solution where more and more molecules can join to the crystal and grow that way instead of being evaporated out. The alum crystals are combining into the initial crystal that is there. So I did get this from one website. I can leave it into the description, but it's Home Training Tools, and then the title of the page is Crystal Growing Newsletter. And so essentially this process relies on nucleation rather than this whole process of supersaturating and then evaporating. Theoretically that should create a large crystal of the alum, and so that answers that question. So again, today is the 22nd of January 2017. I hope all the questions have been answered, and I hope I give a sufficient review on what happened during the lab this week. I think another one is due next week, but that'll be then.